Hi all, I hope my screen is visible to all, right?
Absolutely.
Great. So, very good evening and welcome to this session. This webinar is more to give you a bit of understanding on machine learning. And I believe that you already know about what is machine learning. And so I'm not going to teach you in general, going technical into what is machine learning. But yeah, a bit of understanding I'm going to give you is, or this webinar is going to give you is the idea of how do we implement machine learning in general when it comes to industrial practice, and how is the life cycle that goes in, and what are things that we take care, how do we manage machine learning project, and what are the assessments and analysis that we do while managing a project, how to go about learning machine learning, what should be your ideal strategy or your ideal pathway to enter into the world of machine learning. So that a lot of exciting knowledge, or I would say information, is going to be take away from this webinar. So with that part, let's get started. So first thing, my name is Anshu Pandey. I am a Microsoft certified trainer. I hold a few more certifications, as in I am a Wiley certified trainer. I hold certification as from Microsoft and AWS as certified machine learning and data science and AI engineer. I work as a data scientist and program director for currently I consult for a company which is Board of Ventures based out of San Francisco. And it's been around last 8 years. I have been working as an data science consultant and AI consultant. So as a part of my job, what I do is, one is that I help enterprises to build a data science team. So I train their team on different technologies and help them to understand how to manage machine learning project. Two is I help them to design the AI and data science strategy, transformation pathway, and approach on how do they handle a data science project. I also mentor the data science teams from different organizations across India, Southeast Asia, which is Malaysia, Indonesia, and Singapore, and also Middle East as well. That's about me. So I bring a bit of good experience in understanding how actual projects are being handled compared to the way that you do with Python and in a Jupyter notebook, which is more of an experimentation project. But when it comes to the real project, what are things that we take care, something like that I'm going to cover up in this webinar for sure. Here we go. The first thing that I'm going to start out with is to give you a bit of more clarity on how is that the world of machine learning, AI, deep learning, and data science, computer vision, and NLP are connected, and to give you a bit of landscape understanding of AI and where machine learning falls into that particular landscape. So if we could start with that. So when you talk about the first word AI, it's more like you want to make something intelligence, right? So you say that giving intelligence to machines is what you call as AI. And when you say intelligence, what do you mean by this? It's much more like you can say you make computers to be able to take decisions the way we humans can do. An example could be, let's say, if I'm driving a car, right? And while driving car, if there's somebody on my backside, my wife, and she's giving me commands, Anshu, do this, take a straight and take a left. So when I'm following her instructions, I'm not using my intelligence, right? So intelligence is somewhere where you follow your own conscience and take your own decision without someone else's instructions. We humans always take our own decisions while driving car, riding bike, talking to people, reading languages, right? Playing cricket or singing a song, a lot of it. Whereas the way we program computers is like we write instructions. So we write, if this, do this, else if this, do something else. We write our own instructions to them, right? And computers follow that. So computers and machines generally you can say are not intelligent. So AI is more about bringing this intelligence of capability to take decisions in machines and computers, which could be in any form or which could be approached in any way. That's more of a logical definition of AI. It's like you make computers imitate humans. Technically, it's more like you may have question. Well, I mean, as you're already studying machine learning and AI, you may have already approached this particular logic. But yeah, a technical definition of that could be a bit of idea on AI is more about building or adding some intelligence to machines in a form of algorithms, right? So in the form of algorithms. So a technical definition of AI could be, it's a collection of algorithms, a lot of algorithms. And these algorithms are mathematical formulations developed by researchers in last 50 to 60 years across the world. So technical definition of AI could be its collection of algorithms. And more or less like all of the researchers and I would say research universities and organizations have been doing huge research and spending a lot of time in developing these intelligence algorithms and building applications. So today we use a lot of applications, which are many of these, to in which ultimately some or other way artificial intelligence is used. But if you think about like where machine learning falls into this picture and how is that related to this, let's talk about that mainly, as we are more interested into machine learning. But before we talk about machine learning, we have to talk about one of the very important term which makes machine learning more feasible is data, right? So what is data? Anything which carries some information is data. For example, if I have a lot of pictures on Facebook or Instagram, that's data. Sort of videos on YouTube, that's data. Tweets on Twitter, articles on internet, to emails in my Gmail inbox, or SQL database tables, or Excel sheets, CSV files, everything is data. Anything which carries some information is data, right? So it's like you can say business data or data that we capture from ERP solutions, or in machines in a company we capture data from different ERP tools, CRM interfaces, clickstream data, right, which is generated from the users by customers when they use our web or mobile interfaces. In industry, we capture mainly two types of data: structured and unstructured. Structured is like tabular, unstructured like images, text, which is not organized. And it's quite easier to process structured data because we have sufficient tools like Excel, like SQL, and even more like that, SPSS, SAS, a lot of tools which can be quite effectively used to process structured data. But many of these tools are not so capable in processing unstructured data, right? That's where we need more different approaches. That's where we, so this is all more about generic idea of data. Now, if you try to link data and machine learning, data and AI together, that's where we've come to the topic, which is machine learning. So technically, AI is a collection of algorithms. So you can think of this as more of collection of algorithms. So there are a lot of algorithms under AI, right? You can say no limit, no count of that. Some of these algorithms are the most powerful algorithms are the one which use data, and all of those which use data fall under ML. So you can say definition of ML could be algorithms which use data to learn to build intelligence. You can say under AI we can have two types of algorithms: the one which do not use data are not so powerful, and the other which use data are the most powerful part of AI, and that's machine learning, right? The example of the algorithms which do not use data could be fuzzy logic, could be genetic algorithm, particle swarm optimization, and a lot of other optimization techniques. Example of algorithms which use machine learning could be linear regression, logistic regression, decision tree, neural networks, sorted machines. The most powerful part of AI is machine learning. So when today a lot of organizations are creating a lot of hype about AI, and when they say that we are becoming an AI savvy company and we're using AI in our some or other product and services, what they're actually adapting is machine learning, because the most powerful part of AI is machine learning. And why today so much hype about machine learning and mainly AI? So one of the reason is because of data. The availability of data is one of the main reason I would say behind possibility of or capability of organizations to be able to implement AI and machine learning solutions. So in last 5 to 10 years, if you look at India or any other developing country, almost every hand started having a smartphone. Almost every hand having a smartphone started consuming digital tools or software or interfaces, which could be they started doing e-entertainment, they started doing e-banking with Beam or other tools, they started doing e-finance management or getting recharge into their mobile phones. They started using internet in a lot of ways, and that's where almost every enterprise started being capable of capturing data. That's where almost every organization you'd have seen is starting to have an app, because that app is a gateway for them to be able to capture data. The availability and the capability of being able to collect data is because of digitalization, IoT, and exponential growth of smartphones and digital applications has made organizations capable of capturing and consuming huge amount of data. That has made them capable of using machine learning. So why so much machine learning hype is availability of data is one of the core reason. The other could be the availability of low cost computational capability, right? So earlier it was like, if I look back in 2005, we were having computers with 512 MB of RAM, even 256 MB of RAM. Now we have somewhere around 16 GB of RAM. So much improvement has been done. Electronics has become very low cost. So it's like organizations are able to afford high-end computational infrastructure at a lower cost. That is also one of the reasons behind hike in machine learning, I would say. Then there are a set of algorithms under machine learning, which is what you get deep learning, and they can perform something called automated feature engineering, right? Which is mostly done on unstructured data like images and text. That's more of categories of algorithms, you can say, right? So AI, machine learning, deep learning are categories of algorithms. These are not application-oriented fields, right? So when you're learning machine learning today, and if you ask me how industry uses machine learning, I would say that industry doesn't use machine learning. So they do not use machine learning directly. They use machine learning in one or other form. Let's see that how industry uses machine learning, right? So generally, as we know, that machine learning is something which is applied on data, right? So data is something which makes it very different, right? So this is very key important term. And when I say industry do not use machine learning, so they don't use machine learning directly, right? So what they do is when they apply machine learning on structured data, right? So first they apply analytics on structured data and identify a few insights and business patterns. And on the top of, they apply machine learning to develop predictive models, right? So if we use structured data to, let's say, develop models which can be used to predict whether a customer will buy a product or not, whether the stock price will go up or down, or particularly whether there is a huge risk associated with a lending or a loan in finance or not, or whether a particular site in telecom industry need maintenance or not. There are a lot of ways we use structured data and use machine learning to predict future. And the field which uses structured data and uses machine learning is what we call as data science, right? So which is kind of composed of applying structured data, right? On structured data, we apply data engineering, we apply data analytics, plus we apply machine learning, right? So industry uses data science, and data science is a way to consume machine learning on structured data, right? So nobody uses machine learning directly, they use machine learning. One of the way to use machine learning or consume machine learning is data science, right? So there are less of the cases where you're going to get a job of machine learning engineer. Most of the cases you're going to get a job of a data scientist. And being a data scientist, you need to know machine learning, because one of the core component of data science is machine learning. But data science is very much limited to structured data, right? In India and a lot of other countries, we do not have very fine-tuned line about what is data science and what is part of data science and what is not part of data science, which is very crucial part, I would say. So people expect data scientists to know computer vision also. People expect data scientists to know image classification as well, pretty well. People expect data scientists to know a lot of text analytics, but that's a very different field. So the field in which we deal with unstructured data, and that to specifically images and videos, we call it image processing. We kind of do here is we capture a lot of images, we perform pre-processing on them, let's say resizing them, converting them from color images to black and white, or maybe extracting a particular color out of it, or maybe generating bounding box, augmentation on images. A lot of these parts we do in image processing. On the top of it, if we needed, we apply machine learning. Let's say if I have 20 pictures of happy face, 20 pictures of sad face, I can use machine learning to teach an algorithm how a happy face looks like and how a sad face looks like. It can detect emotions. That's what we call as computer vision. So one of the other way industry uses machine learning is computer vision. So they don't use machine learning directly, but one of the way they consume machine learning is computer vision. Most of the service-based companies consume machine learning in the form of data science. Most of the product-based companies consume machine learning in the form of computer vision, and the third one, NLP. But computer vision is mostly consumed by product-based companies, whereas data science is mostly consumed by service-based companies. Mostly, I would say. It's not necessarily only by them. For example, banking organizations are service-based organizations. They don't have a product, they provide you services. Banking, entertainment, e-commerce, they all use data science. right? But if you look at product-based companies, which could be, let's say, Google, which could be Facebook, they have a product, which is Facebook portal, right? Or it could be Apple, right? It could be Samsung. It could be the smartphone manufacturing companies. It could be Whirlpool, which is manufacturing, let's say, washing machines, right? It could be any other, it could be Siemens, it could be KUKA, or it could be ABB, any other product-based companies which has specific set of products. They consume a lot of computer vision. The third field via which industry uses machine learning is where they apply it on unstructured data, which is in the form of text or speech. And the field is called as NLP, natural language processing, which is where what we do is we develop applications like chatbots, language translation from language English to Hindi or Hindi to, let's say, French or Arabic. We develop applications like sentiment analysis or something like email classification, topic modeling, right? And it could also be speech recognition, right? A lot of these. So they fall under NLP, social media analytics, text analytics. So NLP is a way to consume machine learning on unstructured data, text data. So if you have to search for a job in industry, you should search as a data scientist or data analyst or computer vision engineer or NLP engineer rather than ML engineer. There would be few of the jobs which would be specifically mentioning ML engineer or ML researcher, but those are more of researcher oriented jobs, right? There would be very less of ML engineer jobs. Again, that could be one, right? It depends on how industry structures their team and how do they, what kind of complexity project they're having and what different roles they have, which we'll also see what are generic roles that industry uses. So nutshell idea is the way industry consumes machine learning are the three fields: NLP, data science, and computer vision. Technically, machine learning is just a collection of algorithms, right? It's a technology. Let's say Java is a technology, right? And how people use Java, they use it for web development, they use it for mobile development. So when you have to learn Java, you will only not learn Java, you will have to learn how to use Java to develop a web application, how to use Java to develop a mobile application, or a server application, or a security application, or a game, right? You need to learn applications of Java. Similarly, machine learning is a technological field, collection of algorithms. You need to learn, you need to build your strength on either data science or NLP or computer vision. If I had to talk about quantity of jobs are higher in data science than in NLP and in computer vision. So NLP and computer vision, quantity of jobs are lesser, but the quality and the pay scale is quite higher. That's about a bit of contextual understanding of the fields, right? So in a nutshell, AI, machine learning are used in industry in these three ways: data science, computer vision, and NLP, right? If I have to give you a few examples of what could be the possible applications of data science, that could be, let's say, you can build a application to predict stock prices, which is very generic application, but in industry we don't do a lot of stock price prediction. Rather, while working with few of the finance industries, what we do is we predict the stock movements, right? How is it going to go up or down? We do stock portfolio management using machine learning. We do risk assessment using machine learning, right? We do risk management as well using machine learning. We do trading using machine learning, a lot of these things. So predicting stock pricing is a very I would say fantasy based and a very exciting application. Actually, it's good to learn that, right? For sure. Housing prices prediction, right? These are a few basic examples, I would say. Item prices prediction. You would see one of the very popular example of this could be when you book a ride in Ola or Uber, right? So Uber, you book a ride on Ola or Uber, it uses machine learning to predict fare of ride. So they don't use static calculations, rather they use a machine learning algorithm to predict fare, because the fare value keeps on changing according to the day of the week of the month, and the festival or non-festival. These are a lot of features that algorithm consumes, and it predicts the fare. That's the reason you might see that when you book a ride in morning or evening or weekends or weekdays or beginning of the month or end of the month or festival or non-festival, for the same source to destination, the fare might vary. Predicting customer will buy a product or not, customer will churn or not. In telecom and banking, that matters a lot for retail organizations. Classifying customers into different buckets, predicting risk with financial transactions like lendings, detecting fraud from credit card transactions, customer segmentation into different buckets, stock segmentation, analyzing server logs, right? Predicting whether patient will come back to the hospital or not, or he will or she will go to another hospital because they were not satisfied with the services over here. Detecting anomalies in access management or data control, right? That's an application. Building recommendation engine, like the way you see product recommendation on Amazon or movie recommendation on Netflix. It could be friend recommendation on Facebook as well. And video recommendation on YouTube is a pretty great example. Again, the video recommendation is done on structured data. It is a video recommendation is done on the type of product is unstructured, but the data which is used is structured. That's the interesting fact about that. Well, computer vision, very popular field and exciting applications that we develop here, which is like face recognition is something which all of you would have heard for sure. Emotion detection, detecting human is happy or sad. Character recognition, which is like converting handwriting to computer text. Right, verifying documents, authenticating whether a document is correct or not, or is it the same person. Detecting different objects and classifying image into different buckets. Forgery detection, that means if somebody has done Photoshop in the image, identifying that. Vehicle number plate detection, type recognition of vehicle, whether it is commercial or private or diplomatic vehicle. Self-driving car has many applications, computer vision, where they use camera for lane detection, for detecting traffic signs, for behavior cloning, like analyzing the different situations, and with that, what actions are taken. We have other applications which include like motion detection from videos with somebody is moving in front of CCTV camera or not, right? Restoring images, coloring them, transferring pattern out of it. Predicting action. So if there's a car which is going to take this turn, so whether the car will take a left turn or it will take a right turn, predicting that, right? So left or right. So that's also part of it. So these are all applications built on the top of images or videos. When you say video, it's video without audio, right? Then we have NLP, third field, how industry uses machine learning, right? This is what we do with, we apply machine learning on the data, which is text or speech. Again, in speech, you have two other forms, which is like content of speech and the rest of properties of speech. Content in the sense what person is speaking. Other properties could be the pitch, the frequency, the arrogance, or the context of what being taught, right? So content, whenever you want to process content, we always convert speech to text. And whenever you want to process other properties, let's say I would want to do gender recognition based on speech, or accent recognition, nationality recognition based on speech, that's where we use a very popular mathematics that you would have heard or learned so far, Fourier transform. So if you are into engineering and learning Fourier transform, this is very important, right? When you work with speech processing, this is the key heart of speech processing, I would say. Almost all the speech-based applications work on Fourier transform. So study this very importantly. Right, then other applications of NLP may include the idea of social media analytics, right? So it could be social media analytics, it could be speech to text and text to speech conversion, generating captions from images, translating language L1 to L2, analyzing sentiment, whether a sentiment is positive or is negative. Chatbot is one of the application, like question and answer. Recognizing speaker, who is the person who is speaking out. Personal assistants like Siri, like Cortana from Microsoft, or Google Assistant as well. Correcting sentences. Generating text, that means from one word generating a whole sentence, or from the sentence generating the whole article. Plagiarism check or similarity matching. Topic modeling, identifying unknown hidden topics from a set of corpus or text data. These are a variety of applications of NLP, how industry uses machine learning in general. These are sort of applications. I understand that I'm going a little quick, but yeah, I would be happy if you ask a lot of questions. So these are sort of applications of generally machine learning. And what is machine learning? So as I hope you already know this, right? It's about making algorithms or machines or computers learn from data, right? If I have to give you a very generic application or definition of it, it would be like the way we humans learn or we build intelligence by practicing. A similar way we program mathematics, or you can say we use mathematics to program computers, right? An example could be, let's say, if I'm learning to ride a bike, right, and it's my first attempt, let's say, where I'm going to ride a bike. In the very first attempt, you can say that there could be two possibilities. First, I might meet an accident, or there would be no accident possibly. So when I'm going to ride a bike for the very first time, these are two possibilities. And let's say it's the second attempt when I'm riding bike. Second attempt. Now, if in the previous attempt, if it was accident, what we humans generally do is, if it was X accident, we try to avoid this approach. And if it was no accident, we use same approach. So whenever humans do one task, we get some experience, right? So this is action, and this is experience. And then we use our experience. So when we do next task again, that means we do action again, which is like second iteration. We use our past experience to avoid that approach or use the same approach. And we do this to avoid accidents. So you can say that when we do any action, we get an experience, good or bad. When we do the same thing again in second iteration, we use our past experience to improve our current performance. This is what we call learning. When we repeat this process, we learn to ride bike. The same thing we do with machines or computers. We teach machines how to learn and use your experience and improve your performance. Every machine learning algorithm is almost mathematical formulation of the same principle. So you can say in a nutshell, general idea could be we humans learn from experiences. Whereas how do we program computers? So computers or software, what they do is they follow instructions, right? So how do we program computers? We say that, okay, if this, do this. Else if this, do this. Computers follow the rules which we program them. How do we program them? The idea of machine learning is instead of we humans programming computers, if this, do this, if this, do this, let the computer itself come up with its own rules by using data, right? So the idea of machine learning is use the human way of teaching computers. So the idea of machine learning is let's make computers learn from experiences. And we feed them experiences in the form of data. That's what we call as machine learning. So that's a nutshell definition of it. More a philosophical definition, I would say, right? There's a lot more to discuss in technical definition, but as this is not a training, it's a webinar. I have to go quick with that. But yeah, that's more of a logical idea. Every machine learning algorithm is a formulation of the same principle, where we use the human analogy of learning and program that mathematically using probability or algebra or statistics to make the computers extract information from data and build their own rules. So nutshell definition is it's a field of computer science where you kind of make computers learn from data. That's about it. Now, there are a lot of applications of machine learning, right? So you hear about face recognition, you hear about sentiment analysis, or you hear about a lot of other applications. But when you go to industry, the kind of applications that we actually work on differ a lot from these applications, right? So if you have been practicing machine learning with face recognition or housing prices prediction or stock prediction or diabetes prediction, that's good to practice, but make sure that you understand that in industry, it differs a lot because the kind of applications that you develop as a creator differs a lot with the application that you use as a consumer. So the way you consume machine learning could be from Facebook or Apple or Google, a lot of these players, right? But when you become a creator, when you join industry in a company, you get different challenges. You get different type of problem, different issues which you would have to resolve, which are like this. These are more of terms which shows the problems in a specific industry solved using machine learning. So in manufacturing, we use machine learning for condition monitoring, understanding if if there's an anomaly in a condition of any machine, understanding propensity of a customer to buy a specific feature. Well, let's say if Maruti Suzuki is going to add a particular feature with the car, how is that feature going to increase the chances of customer buying that car? Demand forecasting, telematics for supply chain management, market segmentation in retail or cross-sell upsell analysis in finance, social media for travel and hospitality, and health management and patient health trigger for healthcare and life sciences, right? And users analytics, and you can say more of consumption prediction for for energy and utility segment, are a variety of applications which differs a lot compared to what you see as a consumer, or maybe what you see on Kaggle a lot, or Kaggle applications, I would say, are examples are quite good, more aligned to what you do actually in industry. But yeah, so it differs a lot from the very basic and popular examples which you might do as part of Iris or Titanic, or I would say any other data sets, right? So it differs a lot from that, the kind of challenges. So you might be working on very clean data, which could be Iris or Titanic, or possibly diabetes data. But real data is very unclean, messy, complex, and at a moment you can say so in a format where you can't use it directly. You have to spend a lot of time on mugging and preparing it. I'm not scaring you, but yeah, that's actually a pretty enjoyable work to do. Now it comes to programming languages. Yes, in industry, we use these two programming languages. So we use either Python or R, right? So if you're learning machine learning with Python and R, you're on right track, right? So you can learn any of these two. R programming is very widely used for structured data, and the industries which are on which only deal with structured data, and they want to mainly work with statistics, or they prefer R. And it's a very powerful language for statistics and data visualization. But R fails, or maybe it's not as powerful as Python when it comes to NLP, when it comes to computer vision, when it comes to deep learning. These things are pretty much, you can say Python has quite advantages. So if you're learning any of these two programming languages, you're on the right track towards learning machine learning, because this is what we use in the industry a lot. On that extra add-on skills, I would encourage you to learn about a bit of SQL, a bit of database management, and few syntaxes on SQL would help you a lot to get into industry quite easily. And that would add a weightage to your profile as well. Other than this, there are a lot of cloud tools that we use, which could be, whenever we get a client which is working on machine learning, clients sometimes have preferences that they're using Microsoft Cloud and they want to host their machine learning application on that. So we may have to sometimes develop ML solutions and host it on Microsoft Azure Cloud. Azure offers a lot of machine learning related services for project management, deployment, and version control. Similarly, AWS has that, SAP has Leonardo plugins, GCP has GCP ML, AutoML, and a lot of similar add-ons on which you can develop and monitor machine learning applications. Similarly, IBM has a few platforms. You need not to build very good skills on these platforms at the initial level, but yeah, at the end of the day, you will be definitely using many of these platforms when you get into any role of data analyst or data scientist. What to learn in machine learning? Well, if I say theoretically, it's a lot of mathematics and then programming. But don't get scared with mathematics when I say, because it's not more of core mathematics, I would say, but more of applied mathematics. So you see, there are actually two roles, and you need to pick one of those two roles. When I say machine learning, there are two important roles. One of the role is machine learning engineer, or a data science engineer, I would say. And the other is ML researcher, or you can say DS researcher. So as a researcher, you need to have very core understanding of all the algorithms, how do they work, how they are used. The role of a researcher is more to develop a tailored algorithm or customize existing algorithm to solve a very complex problem. Whereas the role of engineer is to solve very common problems and need not to have very core, deeper understanding of the mathematics behind algorithms. An ML engineer needs to have satisfactory knowledge of algorithms and should be having very good knowledge of how do we implement them and develop solutions. An ML engineer generally solve common problems, which are usual problems that industry gets. Let's say that we want to predict the profit in the next quarter, or why are we getting losses, or we want to develop a solution to predict a churn, right? Or maybe develop predicting the machine damage likelihood, possibly common solutions. They don't work with very complex and new problems which are given to researchers. And so you need to pick based on your strength a role. Are you going to be landing up as a machine learning engineer or a researcher? A researcher, you know, to have very great understanding of application development, deployment of machine learning products, and packaging of machine learning algorithms as projects, monitoring them. These are the skills which an engineer needs very well with context to machine learning. And so when you want to become a machine learning engineer, you need not to have a core idea of maths, but yeah, you need to know applied mathematics. For example, you need not to remember necessarily the formula of variance, but you need to know what to interpret when you look at variance of data. If I had to structure this a bit more, if you have to become machine learning engineer or data scientist, how should you plan your journey? This could be a pathway to plan your journey. The very first step should be you to learn basics of a programming language, which could be Python. The second step should be you should learn a bit of statistics, mainly descriptive statistics. And at the moment, you should learn a bit of data visualization as well. And then do a lot of practice on data analytics project. Do a lot of exploratory analytics. You should take a pause before jumping immediately into machine learning algorithms. Do a lot of practice here about exploratory analytics. Then once you're confident on step 2, you've taken a good pause of, let's say, a few weeks, and you shift to maths behind machine learning algorithms. Understand a bit of mathematics, and then learn how to implement them using TensorFlow or Keras or scikit-learn. Scikit-learn is a good package. Don't underestimate that. It's a very powerful package and very widely used, right? So it's like if I'm a car manufacturing company, I will not sit and manufacture tire. I would buy it from C8. So similarly, even if scikit-learn does it directly, it's good, right? It's good to use it rather than coding it from scratch in everything. A researcher do not use scikit-learn, but an engineer uses a lot of scikit-learn. So yeah, that's a fourth step. And fifth step is a lot of practice. Here we spend few weeks to do a lot of practice. At the moment, when you do a lot of practice, you become a good engineer, but at the same time, you are not at the level where you can develop industry-grade solutions. Then you need to shift and learn about optimization and boosting techniques. Once you're good with these skills, you become a good data scientist or machine learning engineer. You can get into industry quite easily. And then you may want to improve your skills, which is not necessary to understand how to handle big data, because in industry, you will have to handle TBs and TBs of data. They're good tools to do that. For example, PySpark, Kafka, Flume, these are very popular and powerful tools to handle big volume of data and develop machine learning solutions on the top of it. This could be a possible journey or pathway to become a machine learning engineer. Going further, so I believe that I'm reaching out to my timeline, so I'm going to go a bit quick with that, right? So going further, I'm going to give you a bit of structured understanding of types of algorithms in machine learning, which is like, as you already know, that we have 3 supervised, unsupervised, and reinforcement learning. Labeled data you use here, you use unlabeled data here. You do regression classification, but we also have time series forecasting as well, which is ultimately regression classification, but the set of algorithms we use differ a lot. We use a lot of statistical models like ARIMA, AR, MA, and then deep learning techniques like LSTM. Unsupervised learning, you get to work with applications like clustering, anomaly detection, detecting suspiciousness, or fraud detection, you can say. Dimension reduction is very widely used for data size reduction, for factor analysis, and also for feature extraction as well. Recommendation engine, like the way you see on Amazon or Netflix. These are different landscapes. This is typical pipeline that you must be following so far. So you take a data and you split into train and test, which is good part. And this is a standard pipeline I believe you should follow. You feed the train data to the algorithm, and you evaluate using test data, and you do prediction on the model. This is a good framework. If you're following this framework, you're on the right track. So what should be a standard life cycle that we follow when it comes to machine learning? So one of the stuff that we do is we do first, before even starting with the algorithm, we do spend a lot of time on domain knowledge gathering. So if I'm doing a finance project, we spend a lot of time understanding finance industry. Gather more relevant data outside the business. So we spend a lot of time on data exploration and data capturing, then cleaning, and then comes feature engineering. At the moment, we spend around 60% of the time of a standard project, which is consisting of, let's say, 1 month with a team of 3 people. Then we work on pre-processing, and you see, this is the part which is more exploratory and research oriented, right? The first 3 steps. The other steps are more formatted and standard pipeline and structure or template which we follow. So pre-processing based on the current format of data, apply the algorithm, test multiple of them, performance analysis with the right metrics, tuning of it, optimize it, and finally, so at this moment, you're done with a researcher job. And at this moment, you can say a data scientist job is done. Then we come up with a lot of data science engineers and software engineers job. They export the model for production, they do the deployment in production, and monitor the performance in production. This is standard life cycle of a standard data science, which is machine learning oriented data science project. In general ML project, there are 2 phases. The first phase is research stage, and the second stage is development stage. What do you mean by research and development stage? So at a research stage, when you actually get a problem from business, you don't know what is right data, you don't know what is right algorithm, you don't know that what algorithm will work better. So the kind of questions and problems that you try to solve are more of exploratory in nature, which is like, what is data that we have for this problem? Do we have data which is relevant to our problem or irrelevant to that? What ML methods or techniques should I use? Supervised or unsupervised? Regression, classification, or clustering, or anomaly detection or recommendation? How do we assess performance of model? Should I use accuracy, or should I use R-squared score, recall, F-score, or AUC, ROC? Can we do this? Can we do that? All right, or we have to do this. These are more of exploratory or research-oriented questions that you ask or you solve actually. Once you're done with that, then you have a model in hand, you have a good data in hand. Then you think about, how do we deploy this? How do we implement this on a larger scale on 1 TB of data? How do we make this application available to maybe 100,000 customers at a time? How do we build A/B testing environment? So the kind of questions and queries that you have on both stages differ. Teams also differ a lot. So we do one of the other standard practice that we follow while working with a machine learning project is the data quality assessment. So we spend good time on understanding, documenting the kind of data that we're using and how are we capturing it, what customization are we making. So we prepare a quick catalog of that. For example, first we took data from data lake. It was a clickstream data, right? Clickstream data is like when you go to a web page and you do some movement, you click somewhere, everything we capture. And we took data from 2018 to 19, 1.6 million records, and which is consisting of IP addresses and username not known. So we create a data catalog, which is like an audit of how data is changing from day 1 of the project to the date N of the project, if the project is of N days. This helps a lot at the end of project to assess and understand that what changes have we made? Are we going in wrong direction? Or have you manipulated data so much that it's not going to be useful in production? This process, or following a standard structure approach, is very important. At the moment, you may not get into this approach, but it's very important that you always remember a structure. Rather than randomly trying out different algorithms, randomly trying out steps, follow a structure. What steps after what step should be done, and how do you go about that? Right. So yeah, this is one main thing I wanted to focus out. And so yeah, that was one of the main contexts, I would say. And so yeah, that was one of the main contexts, I would say, which we we wanted to discuss out about the idea of how do we work with machine learning project and how do we structure that out. Okay, so that's about it. Now we are done with that, and we are open to questions. And we have discussed out the kind of type of algorithms and what we the context of the topic, right? So we are open to sort of questions at the moment.
Sure, that was perfect. That was a great, wonderful presentation, Anshu. Thanks a lot. Extremely informative for a lot of guys on the chat, I'm sure. We have a couple of questions. Why don't we take up?
Right. So there's a question on which project a student should work on ML field during his college time to get a good work after graduation. So I would say that you should. If you are more of job oriented, I would recommend you more to work on structured data, that is data science projects. Data science projects could be, so at the moment, if you are more job oriented or you're more focused on job, the quantity of jobs are more in the field of banking, finance, telecom, e-commerce. These are the 3 fields which are the highest hiring fields to data scientists and machine learning engineers, right? So if you are more job oriented, you should pick a lot of finance, banking related examples, which are using machine learning, which could be risk forecasting, which could be payment, lending, insurance related, right? And or telecom or e-commerce related. And you should work more on structured data. At the same time, when you work in project, I would also recommend you that use portfolio management. That means from college itself, you can start building a portfolio, which could be on GitHub. So every small code that you write, push it on GitHub. Every small code you write, you can push it on Kaggle as well. You can build portfolio on one of these platforms if you're more focused on job. So these are the fields, and structured data would help you a lot because the quantity of jobs in data science are higher compared to other fields, I would say.
Sure.
I hope that answers your question.
Absolutely. I'm sure that was on point.
So another question is that right now we are aware about ML, but we don't know a specific source where we can go and get industry ready. Can you please refer some websites or books where we can get easy and brief idea? Well, websites are good, I would say, right? I mean, I would encourage, if you see you're more job oriented rather than research oriented. If research is your focus, I would encourage you to read research papers on archive. If you're more job oriented, I would encourage you to do more practice on machine learning examples. To get data sets, Kaggle is a super platform I would recommend. So you should try out and do stay a lot active on Kaggle, and that's one thing. And if you want to read about it, there are a lot of good books from different publishers. You can prefer using Springer. Springer is very one of my favorite publications. So I read a lot of books from Springer. Springer is pretty good publication. You have very standard books, but many of these books do not give you an engineer approach of learning. They give you a researcher approach, right? So they teach you a lot of mathematics. So you need to be very you can say rational in picking what is important at the moment and what is not, right? You need to build a lot of your foundations on statistics. So few of the books I can recommend is, one of them is could be Business Statistics from Ken Black, right? I can write in chat. If you search on internet, there is a free version of this available. This is something I would a good book, and rather than researcher oriented, more of an engineer oriented. That means it doesn't teach you a lot of complex mathematics, rather it teaches you a lot of business applications of statistics and mathematics, how it is used in business. So make sure that you focus more on that, because if you want a job, then you have to focus on a lot on how industry uses a particular application, and this book is one of such example. Other than that, practice a lot of examples on Kaggle. If that answers the question, Vikas.
Awesome. So hey, I wanted to ask you a question. If you don't mind. So I'm a sucker for these interdisciplinary technologies, right? I do a lot of. So I'm a biomedical engineer, right? So my discipline has like biology and electronics in it. So right now, a lot of us are working on stuff like AR and VR, right? Augmented reality, mixed reality, hologram, stuff like that. So I wanted to understand what kind of pressure, so what kind of machine learning is involved firstly, when you are deploying an AR, VR app or a model. So when you look at these Instagram sort of situation, you get those filters and stuff. What kind of machine learning? Because that's real time image processing that's happening, right? So
Yeah.
is there any ML that goes into it, or AI that goes into it? Firstly, yeah, that's my first question.
Yeah. So yes, a lot of it. For example, object detection, shape detection, feature detection are a number of stuff which goes in backside of AR and VR. Because whenever you want to use AR, you would want to always place that argumentation on a specific position. For that, you need to detect pattern and object. So a lot of object detection goes in backend. Popular algorithm these days widely being used is SSD. So SSD and YOLO are super popular in object detection, shape detection, I would say. So yeah, a lot of computer vision is used in this field, I would say. And being in biomedical, I believe that it's more rather than service, it's more a product-oriented field where you actually work on developing products, and that's where computer vision is super important and I would say more suitable to get into at the moment for you.
Sure. So my second question to you is, what kind of pressure does deploying ML or AI models put on the chip of the hardware? So a lot of machine learning platforms are moving on the cloud because your regular computer can't handle the computing that machine learning puts you through. So how do you go about deploying hardware optimized algorithms, or when do you take the call if you should move to the cloud or should you do it locally? And
yeah, so you see there are two types of ML applications which goes in. The one is product based applications. So product based applications, you need to have optimized chips. For example, let's say if I have to deploy an ML application in X-ray machine, so that's where I have to put the ML model, which is the let's say H5 file or pickle file of the model within the machine. That's where I need to, and when it is deployed in the product, there is no pressure of cost or computational load, because there's not going to be parallel people who are going to be accessing it at the same time, right? If you compare ML model deployed in X-ray machine compared to an ML model deployed on Amazon cloud, and so let's say Amazon recommendation system, now there are thousands of people who are accessing Amazon at the same time, millions of people possibly, right? So the parallel request which will go to that model, and that model has to make prediction, will be very high compared to the one which is put in X-ray machine. So when we talk about product-based deployment, we focus a lot on lightweight model, because you have to deploy that in embedded system, and there you don't have to worry about scale.
Correct.
Because you're going to make only one prediction at a time, and the frequency is not at all a problem. But you have to make it lightweight. You have to make it in a way that you can update that. For that, we have very powerful now these days chips available. Even TensorFlow models are more optimized for processing on that. And every model doesn't need a TPU or kind of architecture. Only if your model is processing very high resolution images. For example, if I have to process MRI scan, compared to that, if I have to just process face. Now in face, I may not have to process a lot of, let's say if I have to just detect whether there is a human or not. So I don't have to process complex images. That means my requirement is not very high resolution. Even low resolution stuff will work. So I don't need a TPU oriented chip to process that. A standard processor can do the job. But if I have to do face recognition with an embedded system, I need a TPU oriented stuff, because you need to know very fine-tuned features out of it, right? Or MRI scan, the resolution of image has to be high in that case. Coming back to the cloud part, when it comes to services, let's say if there is a model which needs to be deployed. So we did a job for Abu Dhabi police, right? So the idea was that we were actually detecting so Abu Dhabi is an emirate in UAE, so it has a lot of you can say roads which are coming from different other emirates inside the emirate. Now there are a lot of vehicles which come from different other emirates to Abu Dhabi, and on every street or on every highway there are a lot of CCTV cameras. So in those CCTV cameras capture pictures. We wanted to identify that how many vehicles are coming from different emirates, and what is the frequency throughout the day and throughout the weeks, throughout the days, throughout the week, and all. So every hour there are hundreds of vehicles which come, and we have to identify for each vehicle which emirate it belongs to, and is it a private vehicle, commercial vehicle, or like that, right? So not the number, but vehicle type. And again, let's say if you are doing it in India, you are into a state of, let's say, Bengal. So you may have data of Bengal vehicles, but you may not have data of Gujarat vehicles. You may not have data of the vehicles coming from Delhi, right? So we don't have data of outside emirate. So we have to, all in all depends on the image. And that's where the volume of pictures coming up were quite high, and we had to go for cluster management tool. So we deployed the machine learning model. We wrapped it in a Flask server, which was wrapped in a Docker container, and we created multiple copies of Docker container on a number of servers. We managed that using Kubernetes. So Kubernetes for server management, cluster management, create using Docker container for wrapping up your machine learning application and deploying it on scale. This is how industry follows a standard architecture for service-based application, or for applications where you're going to have high demand and varying demand.
Fair. So the answer to my question is basically it depends on the problem. It depends on what problem you're solving. Okay. Let's take a question by Vinay Kadam. Can you elaborate more on feature engineering? Is it like its job description? What kind of challenges it has on the industry? Because we know that real-life data is very complex in nature.
Yeah. So So you see, the idea of feature engineering is mostly you do manual feature engineering a lot on structured data, and there are standard practices to follow when it comes to structured data. So if I have to show you a screen for that, so yeah, there are standard set of steps, I would say, which are involved into feature engineering, and which depends on the type of data, and depends a lot on the so you can say that these are a few feature selection and feature engineering best practices, right? So it's we do a lot of stuff which is like we do a lot of data exploratory analysis using visualization. There are statistical methods like correlation, ANOVA, chi-square, right? And again, backward chaining, forward chaining, machine learning based feature engineering, importance analysis, mutual information analysis. So these are standard statistical methods, and these methods are quite sufficient to be able to do that. Feature engineering actually is composed of two things, right? So if I say feature engineering, it is composed of two things. One is extraction and selection. Now, extraction is more about when you get data, it is not in the format where you can directly use that. If I give an example of extraction, it could be, let's say, banks, when they store data, they don't store, nobody stores age of customer. They always store date of birth, because if we are storing age of customer in the database, we have to update it every year. So you will get a date of birth. Now you need to apply some mathematics to convert date of birth into age. So this is what we call extraction. So extraction is an art. There's no standard method to do that. As good experience you have with data engineering, that good you can do extraction. So when you get data from business, they haven't stored data thinking that we will be using machine learning after 5 years from now. So the data is a lot sparse and in a format where you cannot apply mathematics directly on that. So one of the step we spend a lot of time on extracting as much as information without using all these methods, without doing selection. Once we are very much satisfied with all sorts of methods that we can apply for extraction, and we have extracted almost as much possible as features, then we go for selection, and where we use kind of these methods for feature selections and analyze the features which are good or bad, right? And when we do a lot of, then we also do on a sample of data, a lot of forward and backward chaining to be able to be sure on the kind of the model that we have is good enough to go forward. So this is a bit of idea. I hope that gives precise answer to your question, Vinay. Yeah. So these are the issues. So few of the popular challenges are extraction. So at times when you work for a service industry, you never know that you don't know the business of the client. So you don't know that what kind of information can be extracted and how a particular feature can be used out, right? So that becomes a challenge. Yeah. So other than that, a lot of businesses do not have right data. They have problem, right? We were working for a Malaysia-based company which was into oil and gas, and they just captured the data of POS, which is sales data, but they wanted to demand forecasting. So they didn't have data at all. So a lot of these days we get challenges. A lot of companies are not mature to have good amount of data. Right. And that's where we end up suggesting them that, okay, these are the data points that you should capture now.
So it's a data aggregation problem.
Yeah, data aggregation is one of the challenge. And another is like they don't know what attributes to capture and what attributes would be useful. Because at the moment, you can't estimate that 5 years from now what problem you will have. And for that, what data should you start capturing today?
Sure. Let's take another question.
So we can take question from Sumit Chaudhary, sir. Right?
Yeah.
So kindly elaborate regarding R programming, as you have advised to go for structured data. So links to read the approach to R programming.
Standard links, I would say R documentation is very powerful one way. Other than that, there are a few pretty good books on R from Springer publication, where I have learned R actually. So I have read a few books from Springer which are pretty good on R. Other than that, our documentation is quite enough. There are few sample codes available on Kaggle which are quite good to read R as well, right? And yeah, so R is very much popular for structured data. A lot of banks, finance organization, they stick to R and they don't go to Python. Research organization, institutions, they stick to R as well, right? And yeah, these are the resources I have used so far. Other learning perspective, I believe few portals are good. For example, DataCamp is something I can recommend. Is a good portal, but that's a paid portal. There are a lot of other paid portals which are good. But yeah, these are the good resources which are worth spending time.
We have two more questions. Like one is from Baba Ki CKT. Okay. So his question is like when we see advertisement in mobile phones, so that our mobile is artificial intelligence, but it is machine learning. Then why they say our mobile is related to AI?
Machine learning is part of AI, right? So when you do machine learning, you're doing AI. So you can say AI is a superset of algorithms. Under that, we have some algorithms which are part of ML. The algorithms which use data to build intelligence, those are part of ML, right? So when today, many organizations are saying that we are using AI, they're actually doing a part of AI, which is ML. There's non-ML AI as well, which is like fuzzy logic. So fuzzy logic is widely used, I would say, in washing machine. You might have seen fuzzy washing, right? So washing machine use fuzzy logic to calculate automatically the number of cycles it should take based on the amount of dirtness and a load of cloth. So there are a lot of algorithms under AI, and machine learning is a subset of that, right? It's just the most powerful part of AI is ML. So today, when somebody says we are becoming AI company, they're actually doing ML. So in mobile phones or Google, you talk about, right? So when you see Google Map, it's an intelligent system. Google search engine is an intelligent system, but many of these intelligence are backed by ML, and you call them AI because ML is part of AI.
Right. All right. Hey, like personal question: do you think AI will kill us?
Not AI cannot kill us. It just if there is a wrong approach for using AI, that can create a lot of losses or problems, I would say. Humans design anything, we always know the drawback of it or the way it can be manipulated.
So yes, so we have one more question from Shashwat Samal. So what are your views on ML being used in medical cases, like example, cancer detection and what more?
In a lot of cases, ML is not being used as the final application, I would say. For example, if you compare two systems or two business domain, finance versus medical. So in finance, machine learning is used as a final decision. For example, you go to some portals, you apply for credit card, a machine learning algorithm decides whether you will get or not without a human involvement, right? So the machine learning algorithm is the final decision maker. But in medical, machine learning algorithms are used as advisors. So algorithms are used as advisors to doctor whether this particular patient may have few situations or issues or not. At the moment, whether it is diabetes or cancers, all of the machine learning algorithms are used as a recommendation system to recommend few patterns, because medical is a very crucial, I would say, and very risky domain where you can't have a less precise application or algorithm deployed in production, right? And it has to be verified a lot because the risk associated with a wrong prediction is very heavy compared to the one which could be in finance or healthcare. So the way it is now being consumed is advisors to doctors, and where still humans are final decision makers.
Exactly.
So there are like just a small thing I'd like to add to that. There are certain applications which are using AI ML in medicine, right? So like all healthcare applications can be categorized into either diagnostic or therapeutic devices. Uh, for diagnosis, AI can definitely botch it up majorly. It can so you go Google that I have cough, it will tell you that okay, you have throat cancer. Okay, but as far as therapy is concerned, ML is actually being used in a bunch of places. A bunch of gamification projects use ML. A lot of research is going on for therapy-based devices use ML. For diagnosis, it's a big no.
Yes. So one more question from Vikas Kumar. So he is generally asking like, do supervised learning help us for COVID crisis? As example, like able to gain a better understanding of the virus or even a reasonable forecasting method. So he is focusing on COVID current situation.
Yeah,
But what's your thought on contact tracing? Because I heard Apple and Google are working actively on contact tracing.
Right, right.
yeah. Contact tracing, a bit of recommendation. Even there are a few challenges on Kaggle which are around, let's say, applying a lot of NLP on a bunch of research data. So there has been a lot of research paper published on different domains, but no one can read all of them. So no one can become expert in all of them. NLP can help us to reveal a lot of interesting papers and clauses, syntaxes, or maybe mentions and research outcomes which could be more related to COVID and can be helpful. So that is one way how it is being used. Other is contact tracing for sure. That's very important and powerful outcome out of it. And the other, I believe, is the way it is being used is to map out the reasons or the patterns, the way it is flowing out. So one of them could be most of the people, let's say, who are getting positive in few days or in shorter number of times are the one who are living in city part of it or urban area of the city, or those who are getting positive in 8 days or 10 days are living in rural part of it, right? So there's a lot of data analytics where clustering and pattern understanding is used in machine learning to reveal a few important best practices or frameworks which one should follow.
So yes, Anshu sir, one more personal question from my side. So
Yeah.
as we all belongs to education industry, right? So it's a general thought to the students, like the students ask, I will be a ML engineer after graduation. So what's the average span of time to become a exact expert in ML in the industry?
So you see, ML and data science consist of three important things to become expert. One is the programming skill, the other is mathematics skill, and third is domain skill. Domain skill and the capability to be able to take right decisions comes with experience, right? So you can't, even if you just keep on practicing a lot of examples, still you cannot become expert until you do a real job. So the moment you enter as a role of analyst, it takes around 1 year to shift and get promoted, or at least 1 year, and mostly 1 to 2 years to get promoted to a role of entry-level data scientist. And from there to become a data science manager, it takes around 3 years another, right? So the entry-level job is never a data scientist or ML engineer. It is an analyst job that you get into.
So I hope everyone understand the machine learning very well. So yes, we will take hardly one more question, sir.
Yeah,
So
please.
yes, so one question is from Pratish Priyadarshini, how ML can increase the efficiency of an online learning platform?
Well, there are few learning platforms I've seen using a machine learning already. For example, let's say, when it comes to learning platform or teaching platform, if you talk about the same thing, machine learning, right? So machine learning is a bit of mathematics and programming, and there are people from different backgrounds who come to learn machine learning. Now, based on the background of people, the kind of concern and questions they have and the interest they have, that might differ, right? So machine learning is used to recommend the set of, you know, courses or skills or examples they should practice so that they go in a right path. For example, let's say if I'm from a manager background, if I just talk about industry perspective, I may not be a lot interested into doing a lot of coding in machine learning and looking at a lot of mathematics at the very first go. Maybe in the very first phase of my learning journey, I would want to learn about how machine learning is being used. But being a developer, I may not want to look at a lot of theory and business examples. Being a developer, in the very first phase of my journey, I would want to see some practical examples of how machine learning is implemented in general. Being a mathematician, I would want to see in my first phase of journey how mathematics contributes to machine learning. So based on the background of the person or the student or learner, the kind of journey that they would want to actually go through, that should differ. Currently, all the online learning platforms and teaching platforms use the same journey for everyone, irrespective of their background, their current knowledge, or their interests. But it should be customized based on what they have been doing, who they are, what's their qualification, and what do they want to achieve at the end. So a few platforms are developing ML-based solutions where they customize your learning path based on your past profile, based on your future goals, and based on your current knowledge. So they take, let's say, test. They ask you a few questions, which are technical and non-technical questions, and they understand your pros and cons. They rate you on a lot of factors, and then they design what's the journey you should get into. Let's say, so person A's journey could be of 3 days, person B's journey could be of 7 days as well, based on their goals and skills. So that's one of the approach how online learning platforms have been using or are planning to use machine learning for teaching.
So thank you very much, Anshu sir, for taking this
Thank you.
session and accepting the request for this webinar. And yes, we will be like going soon for the series 2 very soon, and we are looking forward again with some new topics from your expertise box.
Sure.
Right.
Yeah. Thank you all.